Before I get started, some of you might not know me. My name is Stefan Thomas. I got into Bitcoin in 2010. I started working on it by creating a video about it, trying to get more people to recognize it and notice it as something interesting that's out there. The video got more than 5 million views on YouTube, and it's kind of generally recognized as the main introduction for most people to Bitcoin. Part of the lesson out of the video was that the clients weren't easy enough to use, so I moved on to work on something called Bitcoin.js, which was a Bitcoin implementation in the browser. It spawned a lot of projects that people started. One of them, Blockchain Info, my wallet, where like it came up during the panel discussion, you can actually use Bitcoin in the browser and still have your customers keep the keys. And I kind of dedicated myself to kind of being the Bitcoin in the browser guy. So I was eventually approached by Ripple, and Jed kind of asked me to join to kind of bring that experience into the company. And to be completely honest with you, at first I was a little bit skeptical because I didn't really see like very clearly how Ripple improves on Bitcoin, or why I should put my efforts into this new network. But eventually, after meeting the team and after understanding that there are some key differences, I kind of moved out to the US, started working on it full time. And today, during my talk, I kind of want to bring across some of these differences and what motivated me to spend all this time and all this effort into this new network. So the talk's called "What is Ripple?" And let's see if I can get this working here. I don't have a clicker, so if you can go to the next slide. Okay, thank you. So Ripple is really a protocol for moving value. So whereas Bitcoin is a protocol for moving Bitcoins, Ripple is agnostic to what kind of value you want to use. And that seems like a minor distinction at first, but we'll go into why that's really, really fundamental and why it's really important in a second. So aside from being this protocol, there's also a distributed network that powers it. So as people make these transactions, they have certain things that they need to agree on. And so just like Bitcoin is a global consensus network and a global ledger that gets updated every time someone does one of these transactions. And also, just like Bitcoin, there's a built-in currency, which is used for things like fees, as well as trading. And I'll explain how that works in a second. So, next slide. OK, so that's fine. You can leave that up. So one interesting, or what I really want to get across in terms of how to think about Ripple is it's intended as a protocol. So you think of it as like an HTTP. So just like there's HTTP for websites, you can have RTXP for transactions or moving value. And people have been dreaming about doing this for a very long time, but it's never quite happened. So there have been efforts in the W3C and in other organizations to create an open standard for payments. But because the settlement ultimately has to go through a single organization, you still have that problem where people have to agree on one of those organizations. So if you go, I recently saw an ad from Visa, and their main selling point is that it's accepted anywhere. Whereas like Chrome doesn't advertise the fact that you can view any website. Like that's people assume that, people take that as a given. Whereas in payments, we're not there yet. And Ripple is kind of the first technology that allows you to do this settlement in a distributed way, so that people literally just integrate with Ripple, and they don't have to worry what happens on the other end. They don't have to worry what currency their counterparty uses, which bank they're using, which payment network they're using, whether they're credit-worthy or not. The Ripple network takes care of all of that, and all you do on your end is worry about which gateway you want to use, who should hold your money, what currency your value is going to be in. So it kind of takes that side away. Ripple, like I said, supports any currency. It's completely global, just being online. So it inherits a lot of the same benefits that any open protocol has. It's final, which means that any transaction that happens can't be revoked. That's kind of a slight distinction to Bitcoin, where if someone were to generate a longer chain of proof of work, any transaction can, in principle, get revoked. Whereas in Ripple, any transaction is final, as long as you trust the security model of certain validators. And I'll explain a little bit more about that later. Transactions in Ripple are quite fast. The Ripple protocol uses something called continuous ledger close, which essentially means that we try to generate the new ledger as soon as we can. So once the ledger closes, we kind of look at how long it took to close it, and then we try to set a ledger close period for the next ledger that's about the same amount of time. And if we notice the network is overloaded, then we'll extend the time. If we notice the network is idle, then we'll decrease the time. And then transactions are almost free. And once again, the fees are only there to protect against spam, so we can keep them fairly low. So in terms of the confirmation, there's some things I want to contrast Bitcoin to Ripple. Bitcoin uses mining-based consensus, so people will mine on blocks, and we kind of assume that the majority of mining power is in the hands of the honest people, and the dishonest people will never be able to get that majority. And that has largely held in the past. But one thing that I want to point out is if you look at cases like DeepBit and Ghash, there have been cases where single pools kind of were threatening to go above 51% mining power. So it's really the mining assumption hasn't really held, but what has held ultimately is the social contract that underlies these pools. So even though they were in a position where they could, if they had wanted to exploit the network, they still didn't. They actually intentionally tried to get their customers to leave, increased fees, stopped accepting new miners, these kind of things, in order to get back below 51% mining power, because it's pointless to be the owner of a mining pool of a centralized currency, because a centralized currency doesn't have as much value as a decentralized one. So mining pools almost self-censored in a way. And we believe that with consensus, we're kind of tapping into that social contract that's underlying the mining assumption as well. And we're kind of trying to cut out that extra layer in between. Yeah, again, you can see the difference in confirmation speed. And yeah, we don't need mining. We still do some useful mining where we use it as a way to give away XRP, but it's not fundamental to the design of the network. Okay, so now go into a little bit more detail about how Ripple works. There are these 4 main groups of participants in the network. Those are not encoded in the protocol or anything, and as far as the protocol is concerned, there's only accounts, and all of these people would be accounts. But based on how people interact with other people in the graph, you can kind of assign these different roles. So there'd be the user who just wants to pay someone or wants to send money to someone. There's the merchant who just wants to accept money from people. There's market makers who make the actual funds flow happen, and again, that's going to be explained in more detail. And there's gateways who do deposit and withdrawal and also hold the real assets that the network is transacting with. So go into a little bit more detail about gateways specifically. If you want to have a distributed exchange, you basically have one of 2 main options as how you want to go about it. One is you can have some sort of virtual value where like a virtual currency, and that's the kind of model that, for example, BitShares is proposing, where essentially you're not really holding the asset. There's no real gold in a vault somewhere, but you kind of assume that the virtual asset will be high enough in value that anyone who buys it on the network will be able to follow that price increase that their asset has. Now, that assumption is a little bit unproven. The more traditional or conservative assumption, or the more traditional conservative approach would be to actually hold the asset, in which case you can be pretty certain that, or you can be 100% certain that if the value rises of that asset, you will have the asset to cover it. So for example, if you want to have gold in a distributed network, you can come up with some sort of gold, Bitcoin-backed gold, and you can hold Bitcoins. But the problem is if gold appreciates against Bitcoins, you might not have enough reserve to pay people back. Whereas if you hold the actual gold, you always have the asset that people actually think that they hold. And so with Ripple, if you want those assets to be held somewhere, that's a physical location. There needs to be a physical party who's actually got a wallet that actually has gold in it. So that's how we do it in Ripple. So when you're actually transacting, you are only ever interacting with your gateway, and the Ripple network kind of takes care of the translation in between gateways. So you don't have to worry about how your gateway is connected to your merchant's gateway. That literally doesn't matter to you. Can kind of abstract that away. So whenever you make a payment, you just say where you want it to go, and you sign it, and it's off, and then somehow it gets converted. And that's kind of the next part of the talk, is to kind of explain how that somehow works. So let's say you have Mexican pesos and you want to send someone Korean won. How does that one currency turn into the other inside of Ripple? The way it works is we have all these different currency pairs. And when I say these pairs, I mean you have a currency issued by a specific gateway. And we kind of treat currencies, even if they are the same currency code, if they're issued by different gateways, we kind of treat them differently. So if I start a gateway, I can just create an account and I can issue trillions of dollars. But those are not real dollars because I don't actually have those in my vault. So for something to get value in the network, there has to be users that trust the gateway and that actually are willing to transact those dollars for other dollars in order to give them value. Otherwise, they don't have value in the system. Can I get the next slide, please? Okay. So one asset that I want to highlight specifically is XRP. XRP are native to the system. So unlike gold or dollars or whatever, we don't have to hold them in a vault somewhere. The system is actually authoritative as to who holds XRP. So if the Ripple network says you have this much XRP, that's true. That's the final answer. And as such, XRP don't have a counterparty. There's no one whose vault you have to trust that it doesn't get broken into. And because it doesn't have a counterparty, we kind of cut out that trust step, so you don't have to trust anyone for XRP. It's kind of implicit. If you're using the network, you're kind of implicitly saying, well, I'm willing to accept XRP. I'd rather have some XRP than none, so there's really no risk for me. And if you're doing this kind of market making, there are too many markets for market makers to serve every possible combination of currency pairs. You saw that chart with 1,000 lines going across. The number of combinations goes up exponentially as you add each individual gateway. And so one thing that kind of happens, and this is the same thing that happens in Bitcoin, is that people tend to create markets with XRP, and then with XRP to the destination currency. And also in traditional Forex, that's how it works. Like if you want to convert Swiss francs to Thai baht, you don't, there's no direct market for that. You convert them to dollars or euros or one of the major currencies, and then you convert them on. And that kind of gets rid of this problem where you have to capitalize a huge amount of currency markets and actively trade on all of them. Now, XRP is not necessarily, it's not hard-coded or anything to have this function, but it offers itself because it doesn't have a counterparty, so it's much more, it's much easier to hold. Now, it's perfectly possible that there would be other intermediary currencies, and it's also possible that you can trade directly between two currencies, but it's still kind of the way it's working out so far is that most of the paths that people use or that you actually get when you're transacting will go through XRP on some level. So the question is, like, given all these features, what is the opportunity for developers? Why should you spend time on this? Now, first of all, Ripple is completely open source, so even if Ripple Labs goes away, even if the Ripple network as it currently exists goes away, the code is still out there. There will still be people carrying on the torch. And we believe that it'll influence any successor network or anything like that might come up. Obviously, we hope that we can make this one successful, but it's open enough that you're not tying yourself to any particular company or technology. It's fundamentally new, so what I'm trying to say with that is kind of this protocol aspect. So we're kind of opening the doors for something that hasn't existed before, kind of this experience where you don't have to worry about whether your merchant happens to accept the same kind of credit card that you happen to have, or whether your merchant accepts PayPal and you want to pay with PayPal or something like that. You really can pick any payment method anywhere in the world. The merchant can pick any payment processor anywhere in the world, and it's the settlement is completely open. It's an open protocol in between, and that's the vision, right? It's like we don't want people to adopt our settlement house. We don't want people to adopt an open settlement network, which the Ripple network represents. So I think it's a fundamentally new thing, and I think it has the potential to completely change how you do payments online. The third point is because we're kind of pushing these APIs onto financial institutions. So like when we go to a gateway, we'll say, you should join the Ripple network, and we'll make a great deal for you. You'll get all these incentives. But hey, in order for you to do, or if you want to get these incentives, you have to open your APIs. You have to make it possible for developers to build against your service in a way where people can use their Ripple identity through third-party applications and interact with that service. And we're at the pretty early stages of that, I would say, but we're trying to build out this whole identity system where you can take your Ripple identity from one application to the next. So if you're building an app, you could use a Ripple distributed single sign-on, which is kind of like a Google Connect or whatever, but it doesn't rely on a single server. It just uses the Ripple network to authenticate people. And once you have that, you can have people bring their financial history, their trustworthiness, their money into your app and use it and transact with it. And that's fundamentally new as well. So we're kind of trying to build out this ecosystem of APIs, of tools, of standards, where if you're building a financial app, it feels a lot more like building games or building other types of apps that aren't subject to this locked down infrastructure that the financial industry is suffering from. So I think it's a very interesting space to be as a developer if you want to build like new things. And also there's a powerful core functionality, and you don't have to worry about how it works necessarily. So the Ripple network basically consists of this graph of trust lines and so on, but you don't have to find paths through the graph yourself. There's a path finding command that you can use, and it'll try to convert whatever you have to whatever you want the recipient to receive. So you're kind of building on top of these APIs. You're building on top of the developer tools that we're planning to release in the next couple of weeks, and you don't have to worry about necessarily how the network works, how it works on the inside, but rather you can look at it as a utility, just like you look at the internet. You don't have to necessarily worry about how the routers are set up and so on in order to send a TCP package. So we're kind of trying to abstract all of that complexity away from you. And again, we're on the pretty early stages of that, but we're definitely making progress. And so again, some of the things that are in store for you is we have a new developer portal coming on. We had just brought on Ryan, who's going to be like a full-time developer liaison. He's kind of spearheading a whole project for how we're going to communicate with developers, how all of our documentation is going to be organized, and reworking a lot of that to make it much easier for people to get started building on Ripple. The next thing is there'll be new APIs and tools, so you won't have to necessarily interact with RippleD directly. There will be tools and APIs that are simpler, that are easier, they're abstracting, again, a lot of the complexity away that you can use, and they're kind of boilerplate. You just download them, you install them, and you can talk to them right away. You don't have to connect to a Ripple network or anything like that. It kind of all works out of the box. And then finally, there are developer giveaway programs, so we're trying to incentivize, compensate people for their time, incentivize building on Ripple. So definitely watch out for those kinds of profit opportunities as well, just to see like where you can contribute. Okay, and just to explain a little bit about the company that we represent and how Ripple Labs is able to do these things and how we're planning to help you. We are founded in 2012, towards the end, so we're in operation just over a year. We have currently 40 employees, and that's rapidly growing. So a lot of our time is spent, just building out the infrastructure in order to support the network, in order to respond to all inquiries, and help people out there build on this new platform, create demo and example applications, create all of these standards and APIs and tools for you. We have a certain amount of venture capital funding. We also have funding through XRP based on people investing in it. And we're working with very great partners in terms of like compliance, getting the regulators happy with the system, and making people understand how it all works together. So I hope that was kind of an interesting overview, and I'm going to stick around for a little bit to take some questions. If there are no questions, then I will go back to bed. Okay, there's one over here. You want to go up to the mic real quick?
Hi. I know that there are some concerns about the Bitcoin network being able to handle sort of credit cards, level volumes of transactions. How does the Ripple network scale? Mm-hmm. As can there be billions of dollars and hundreds of millions or billions of transactions per day? Would that be possible?
So one interesting difference that we didn't really get a chance to get into is talking to Peter and Gavin. I think there's a difference in between Ripple and Bitcoin also in that the Ripple network has a lot more people working on the actual core. I mean, we now have a team of about 6 C++ developers who are just dedicated to working on the Ripple core protocol and the Ripple D daemon. So we're able to implement some of these harder to do features like worrying about scalability and so on. I think on a different time scale that people can in Bitcoin. In terms of what the scalability challenges are, I think they're pretty similar in a lot of ways. The differences mostly come from the different consensus process. And also there's a slight difference in that we anticipate Ripple nodes to be run mostly by professionals and major stakeholders, such as companies or major market makers and so on. So we might be able to assume a higher level of competency in the part of the people who actually run the Ripple Ds. And they can also be a little bit more expensive, so we can do things like scale across multiple machines and so on, whereas Bitcoin's kind of trying to keep it to a level where your average home computer can keep up with the network and can at least process transactions. So there are some differences, and ultimately I can't really predict how it's going to play out in practice, but I certainly feel confident that we have a good setup for scaling Ripple. Okay.
Hey, Stefan, I hope you feel better soon.
Thank you.
I just wanted to ask you if you felt like shedding any light on contracts, which were touched upon earlier, and in particular when they might be part of the system.
Got it. So on contracts, we just hired a C++ developer who will work on them full time. That's basically the goal there, is to build a testnet out that is running contracts, hopefully within the next couple of months, where you can actually run them, play around with them without it impacting the main network, which has already quite a lot of volume going through it. So we want to be very confident before we deploy contracts to that. It is a very scary feature to do because you're running untrusted code on the network, so we're going to take our time with it, and we're going to make sure it works. Another thing that you can kind of look for is we want to build some of the tools to create contracts with. So you want to build like a sandbox that you can run in your browser. You can write contracts, and you can execute them against a virtualized version of the ledger, and kind of see what they do and how they work, and and kind of figure out the code and so on. Those will then eventually run unmodified on the Ripple network. So we're kind of trying to get it to a point where you can basically start coding and playing around with it instead of just waiting for us to get it all finalized and deployed.
So I guess just to clarify for everybody, those are going to be Turing complete scripting language enabled contracts, right?
So yeah, it's going to be the first implementation of contracts that is Turing complete, and we also have this 2-stage execution model where one of the stages is able to be non-deterministic. So we can run contracts that don't necessarily have to always result in the same. Don't always have to have the same result on every platform, but rather we want to give people the tools to make the deterministic contracts if they want to. Just like you're writing a C++ application, it's very easy to make sure it always has the same result. But we don't rely on that as a design goal or as a design security requirement. And again, that gets a little bit too much into depth to try and talk about that. But eventually, in the very far future, this will allow us to do things like create dependencies onto the real world. So for example, a contract might be able to request something from HTTP or might request something from DNS, which is something that other networks that they're trying to do Turing-complete contracts, but they're deterministic, aren't able to do.
Cool. And real quick, are they going to be able to reference each other within the network?
Yeah, so space is extremely expensive. Space in the ledger is extremely expensive. And we anticipate people, uploading entire, language interpreters, entire libraries into contracts. And so it's very important for us that we enable code reuse so that if someone uploads a major library, everyone else doesn't have to upload the same thing, but rather can just reference it. That won't be in the first version. The first version will be kind of pretty simple. It'll probably be a very basic JavaScript engine that's sandboxed using native client. And that will run a copy of RippleLib, and then your contract will be some JavaScript code that runs inside of that. but ultimately will open up the entire stack all the way down to the native client sandbox so that you can build your own language interpreters or your own custom cryptography and so on and upload that as a contract. So that's kind of the vision, but it's obviously a long road to get there.
Is there any number you know about the capacity of the transactions? Like how many transactions per second you can handle?
So we have done some testing. A number that gets thrown around sometimes is 1,000 transactions per second, which would be enough to do, pretty mainstream type volume. But obviously, that's under laboratory conditions. So if you want to get to that kind of level on the open network, there's a lot more testing and a lot more streamlining of potential network bottlenecks and so on to be done. But that's kind of what we're aiming for. So in the current design of Ripple, we're kind of aiming for 1,000 transactions per second, but we're not there yet.
Could you elaborate a little bit on a higher level why someone would want to use contracts and kind of what the advantage of contracts are over Bitcoin scripts, maybe?
Sure. So Bitcoin scripts, first of all, for those who don't know, is basically it's a way to create additional rules on top of which who can spend a certain Bitcoin output. So again, I don't want to go into a whole explanation of how Bitcoin works, but Bitcoin transactions have essentially inputs and outputs, and the way the security works is that if you're trying to spend money, you have to authenticate yourself as the owner of those Bitcoins by fulfilling whatever the output says you should be doing. And that can be with Bitcoin scripts. It can be a little bit more complicated set of behaviors. But Bitcoin scripts are ultimately still, they only return one bit, which is either it's a valid way to spend that output or not. They cannot have any persistent data stored. Bitcoin is a very special purpose database. So a lot of applications map to this way of processing scripts, but a lot of other ones don't. So for example, Namecoin decided to create their own network as opposed to building on Bitcoin just because it's very hard to kind of retrofit those kinds of use cases on top of Bitcoin. There's essentially two things that a distributed network does. One is it provides a predictability in terms of what it's going to execute. So you can kind of look at the code and you can say, okay, as soon as I submit this transaction, this will happen, and I can kind of rely on that. And there's no single party that I have to trust to actually do it this way, but rather I can see the code myself, and this is what's going to happen. The second property is that these distributed networks like Bitcoin and Ripple can come to consensus. So when something happens, it's not like it happened this way here and it happened that way here, but rather everyone kind of agrees on the ultimate result. And those two features are useful for all sorts of applications in terms of escrow, more complicated financial transactions, if you want to do subscription payments or recurring payments or loans or interest and whatnot, demurrage. And a lot of these things, people come up with these cool ideas and they come to us and like, can you implement this in Ripple? And we kind of we say, this is out of scope. We can't do all of this. But what we do want to do, and that's where contracts kind of comes in, is that we want to make available to developers out there these two fundamental properties, which are, you can see the code up front, you can trust that that's what's going to run, and the other one, the consensus that ultimately there will be one result that everyone agrees on. And there's, like I said, a lot of applications, namespacing, tracking ownership of assets, all this kind of stuff that maps very well to this metaphor. So it's obviously impossible to predict what people will build, but that's kind of the space that contracts kind of opens up.
Thank you.
All right, thank you.
Thank you, Stefan.